This is section 8.6, Common Logarithms. Our objective today is I can solve logarithmic equations. Example 1 says to use a calculator to evaluate each expression to the nearest 10,000th. So as you can see in example A and example B, there's not a small number right in this area as there usually is. So when there isn't anything there, that just means it's going to be log 10. So anytime you see just log, that means that the small number is actually 10. So this we could also say log 10 of 5. So we can say log 5 or we can say log 10 of 5. And what this means, this is just the common log that is used a lot. So instead of writing the 10, they just write log because it's common. So anytime you see it, that means there's a 10 there. And what's really nice about these problems is that they're just wanting us to use our calculator, and you actually should have a log button on your calculator. So you'll need to find that, and you'll want to hit the log button, and then you're just going to type in 5 because we're trying to find log 5. That's going to give you a decimal. It says that they want us to round to the nearest 10,000th. So let's go ahead and write out the decimal, and then let's think about where we're going to round to. So the decimal is 0.69897000043. And they want us to round to the 10,000. So remember, let's count these. This is the tenths, hundredths, thousandths, and 10,000ths. So they want us to round to the 4th decimal spot. So remember, when we're rounding, we want to look at the place behind where we're rounding, which is the 7 here. And the 7 tells the 9 to bump up, to go up, because 5 or greater tells the number in front to go up 1. The 9 can't go up, so we're going to actually bump up the 8 here. And so the 8 is going to turn into a 9, which means we're going to have 0.6990. So we bumped 89 up to 90. So 0.6990 is going to be our final answer. On B, it's the same type of thing. We're literally going to type this into our calculator. So we're going to put log, and then we're going to put 0.3. That's going to give us a decimal, which in this case is negative 0.5228787. And remember, we want to round here. So 1, 2, 3, 4. The 7 tells the 8 to bump up. So our final answer is going to be negative 0.5229. Example 2 says to solve each equation and round to the nearest 10,000th. So if you think back, you remember one of the log properties is that if we have a log with the same small number on both sides, we can get rid of those. And the opposite of that also holds true, and that's what we're going to do to be able to solve these. So we're going to actually add a log on both sides so that we have log 4 to the x equals log 19. And now we're going to use some of our other properties. So if you remember the power property, that means we can move this power to the very front. So we have x times log 4 equals log 19. And now we want to think, how do we get that x by itself? Well, I can divide both sides by log 4 so that the x is completely alone. So now we have x equals log 19 over log 4. And that's something that I can actually put directly into my calculator. And that's going to end up giving me 2.123963757. Okay? And when you put this into your calculator, you want to make sure you put the 19 in parentheses and the 4 in parentheses. And now we're going to go ahead and round to the 10,000 spot. So 1, 2, 3, 4. The 6 tells the 9 to go up, but it can't. So it's going to be 2.1240 as our final answer. Same type of deal on B. We're going to go ahead and we're going to add a log to both sides so that we have log 3 to the power of x equals log 15. We're going to move the x to the front. So now we have x times log 3 equals log 15. And then to get the x by itself, we're going to divide by log 3. So that x is equal to log 15 divided by log 3. And if we put that directly into our calculators, making sure we put those parentheses around the 15 and the 3, we're going to end up with 2.46497352 and then we're going to go ahead and round. Again, the 7 tells the 9 to go up, so we end up with 2.4650 as our final answer. If the logarithmic expressions have different bases, we're going to use the change of base formula, which you can see is given to us here. Now notice, in the example that they gave us, the small number was 3, the big number was 11, so this is when the log doesn't have that small base of 10. So we want to look at this and see, okay, the 3 is actually on the bottom, so we did log 10 of 3 on the bottom, and then the 11 moved to the top, so we had log 10 of 11. So we're going to follow this formula to be able to solve example 3. Which says express log 3 of 20 in terms of common logarithms, then round to the nearest 10,000th. So first, we're going to go ahead and express this using our common log, using that base of 10, so like they did up here in this example. So I'm going to go ahead and write this as log base 10, and based off of the formula, we're going to have another log base 10. And our equation originally, I'm going to write that here, was log 3 of 20. And based off of the formula, we see that the small number here went on the bottom. So here the small number is 3. That's going to go on the bottom. And we see that the large number went on top. So we're going to take our large number, which was 20, and put him on top. So this is writing it as the common log, and then it also wants us to evaluate. So all we have to do, and even though the little base is 10, remember that's what it means in our calculator. Just plain log is log 10. So we can put into our calculator log 20 divided by log 3, making sure we put parentheses. And then we're going to get our final answer, and we're going to want to round. And so after we round, we're going to end up with 2.7268 as our final answer here.